Hey everyone, Chang here. Welcome to my channel. This is the Bare Minimum Algebra series. Today we're going to spend a short amount of time and talk about comparison operators. Now there's 8 common comparison operator that you would normally see in math, particularly in algebra. So let's go over each and every one of them and how to remember them. Let's talk about the first four. We have greater than, less than, greater than or equal, less than or equal. Now, an easy way to remember this is that you are reading from left to right, whether the arrowhead is pointing one way or the other, you're always reading from left to right. Now, how to remember this? The best thing to do is, I think there are certain analogy about how this is almost like an alligator. To me, just look at the arrowhead. The larger side, the one the opening, that's where the bigger number is usually located. The smaller side, the point, is where the smaller number is usually located. So if you're reading the symbol from left to right, the bigger than the small, so it's greater than. If you're reading the symbol from left to right for this one, the small point, then the bigger, is less than. And you have the greater than or equal. To remember that, fairly simple. It's very similar to the greater than or less than symbol, except for now you have a line on the bottom of it to indicate the or equal. The next four symbol is the approximate version 1, the not equal, the equal, and the approximate version 2. Now, I wanted to differentiate between approximate version 1 and approximate version 2, even though I feel like it's sort of convoluted in the way you see it out in the wild. Now, approximate version 1, this symbol, usually I see it in the form of an equation, basically a mathematical sentence, where whatever the operation, whatever you're doing, it's about that answer, and they use this kind of approximation. Whereas approximate version 2, I often see it as more standalone, where if you're just talking about the answer, you're just talking about some specific statement, it's usually a number. It's about that number. So it's only that one, and there's that two, although I have seen situations where they sort of just intermix it, or someone prefer just this symbol, or someone just prefer this symbol, and then they just stick with it. So just be very careful. If you start seeing these two intermix of symbols, it's probably very good to clarify, read the text, ask the instructor to see exactly what they really mean about these two symbols. Now, the other one is fairly simple. You have the equal sign, which hopefully is the most familiar one that you guys are going to be seeing, using, working with. Because guess what? A majority of the time, these are the sentences you're working with, the math sentences, right? You're trying to solve one expression equal another expression, and through manipulation, you figure out whatever the problem is asking you. The symbol, not equal, is very similar to the equal sign, but all you have to do is just put a slash on it, indicating that no, that's not true, that is not equal. So there you go, you have your not equal and your equal. Then you have your, once again, approximate version 1 and approximate version 2. All right, so let's just start off with these symbols right here with examples, right? The first one is greater than, because guess what? Larger than smaller, so reading from left to right, greater than, usually the one on the left-hand side is the bigger number. So in this case, 7 is bigger than 5. Very simple example. The next one, equally as simple. Wow, nearly bit my tongue there. All right, so this one right here is the smaller, the pointier side. This one's the bigger side, reading from left to right. That is your less than symbol. So the number on the left-hand side should definitely be smaller than the number on your right-hand side. 6 less than 10. Very simple. Now, here's the other ones. Greater than or equal, less than or equal. So 8 is definitely greater than or equal 4. Greater than, bigger, or equal. That's why we have this example. It looks a little odd, because normally if we see something like this, of course 3 is equal to 3. But because the statement is greater than or equal, one or the other, right? This is equally valid. This is equally valid. Same thing with less than or equal. This is equally valid. So is this one, even though our gut reaction wants us to just say 6 is equal to 6, of course, right? But these are all true statements. Let's move over this side. Here we have the approximation, right? Let's just say 3.9, and then the bar on top means that it just goes on forever, plus 2.9 goes on forever. There's arguments of what that actually equal to, but let's just leave it at that right now. That's approximately 7. So you would see these kind of approximate symbol. So about, close to equaling 7, usually as one whole sort of mathematical sentence like this, right? Then we have our not equal. Basically, the two sides don't equal each other. 10 is not equal to 12. Plain and simple. Now, equal sign, usually we see it in the form of a mathematical sentence, either with variables or just numbers, so on and so forth. One side is equal to the other side. 7 plus 3 equals 10. Hopefully that is not new news to you guys, right? And the last one is the approximate symbol, where it's usually just standalone. So for example, nothing, or maybe you're just talking about it in a specific context, just a number. Here it's about 5, and you would usually see it something like this. Sometimes you would see it with the 2 squiggly, but I've seen it this more often if you're just talking about the number itself. So there you have it. The 8 symbols: greater than, less than, greater than or equal, less than or equal, approximate version 1, not equal, equal, and approximate version 2. Those are the 8 common symbols that you would see in algebra. It's not all encompassing in any way, and I am sure there is a ton more other symbols that you will see. Definitely feel free to share them in the comment section. Or if you know specifically, you have a very technical, surefire definition on when to use this and when to use this, please definitely share it, right? If everyone can be on the same page, we won't have to worry about what that could potentially mean based on the bias or the desire of the author or whoever's writing that specific math statement, problem whatsoever. Anyways, thank you for watching. Hopefully this clarifies some of these things. If you haven't already, please like, comment, and subscribe. I will see you in the next video.